So let me know if you can see my screen. Okay, all right, good. So I will have today we're gonna start actually gonna start a test review for the second test. Okay. If you still have if you still have any question about the test one, I will answer your question individually because most people, some people, several people already complete the test one. Okay. Today we're gonna go ahead look at the test two. I just also share a link. Okay, so if you go to the course here, I just post a link about on the announcement. This one is about the course PowerPoint. Okay, so this is the course PowerPoint. I just posted a while 5 minutes ago. All right, so if you open this link, you will see the entire course PowerPoint about 1342 statistic. Okay, so this is the PowerPoint. Usually we will do this one for the in-person lecture. We will go through every slides one by one in here. So for example, the test two, you will include chapter 3 and let's see what is on test two. If you go to look at the syllabus in here. Okay, so test two, you will include chapter 3 and chapter 9. Chapter 9 basically is the linear regression, so it's only two sections, 9.1 and 9.2. All right, so this is chapter 3 is about the probability in here. Okay, so you will look at this weekly assignment in here. Chapter 3 is about the probability. And then chapter this is according to the 16-week schedule. Okay, I'll change this schedule in here to the mid-hour in here. So this is, but it just let you know, like the if you look at this online schedule, this is update. Okay, so this is the update one. I didn't copy this one to the syllabus. All right, so basically the test two will include chapter 3, which is 3.123, and then 9.1, 9.2. One thing is 9.1, 9.2, you can all use a calculator to do that, okay? I do not recommend you, even you can print out the formula C for this, the entire chapter, but I do recommend you to use this one using the calculator instead of using the formula, because the formula for the regression and the correlation coefficient will be really big. Okay, if you calculate by the formula, one formula probably gonna take you 10 minutes at least. All right, and not giving you will get it right or not. So 9.1, 9.2 strongly recommend just using the calculator. And I will show you how to use the calculator in there. Okay. So chapter 3, we only require 3.1, 2, and 3. We can go ahead and look at this PowerPoint very quickly before we come back to look at the review in here. All right, so the PowerPoint I share with you is already posted, but I will also have one right here. Oh, that's the review. Okay, so let me go ahead do the PowerPoint. Just open a PowerPoint to let you know what is in here. Okay, let's go ahead and look at the announcement using this one. So you will know exactly where to get. Close PowerPoint. And then open this one. All right. So we will have a 3.1, 2, and 3 right here. Okay. Let's see what is on 3.1. It's talking about the probability. All right, so what is the probability? Probability basically, we're gonna have an additional rule and then a basic counting of the probability, conditional probability in here. Okay, so probability basically talking what's the chance of running today or what's the chance of running tomorrow, right? So if the chance of running tomorrow will be 0, that means it's impossible. All right, so probability basically is counting between 0 to 1. 1 is 100%. We do not using the negative number for the probability. So, when it's 0 means impossible. Okay, so that's the basic concept of the probability in here. You can see all the objective and the probability experiment. And then you will learn one more new concept is called a sample space. So what is the sample space? Sample space is the set of all possible outcomes. Okay, and the event consists of one or more outcomes, and it's a subset of the sample space, right? And then you have a chapter video. You can go through the chapter video on your own. I'm not going to play the video here today because all the video also embedded in a homework area, so you can do this one on your own. If probability, if the outcome is only 1, this kind of event is called a simple event. Okay, and first you have to be able to identify what is the sample space, right? If you loading a die, you're gonna have a 6 sample space. It's running from 1 to 6. Okay, and the event of getting an even number will be 2, 4, and 6. Since this one got 3 outcomes, so this one is not a simple event. Okay, it's not a simple event in here. If you just toss a coin, you're gonna have a head and tail. All right, so that's the sample space. And the event to get a tail will be a simple one because you only have one tail or one head. All right, so that is the simple event in here. Tossing a head and loading a 3, you only have one outcome. So that is a simple one. Okay, but if you want to tossing a head and loading an even number, you're gonna have a 3 outcomes. So this one is not a simple event in here. All right, so those things we are talking in this case, you will need to be able to identify. Okay, and then we also talk about the fundamental of the counting principle. So this one is if you have false out, like you want to purchase a new car, right? And you have 3 manufacturers in here, Ford, GM, Honda, and then you have a 2 car size, and then you have 4 different colors, white, red, black, green. So what is the total outcome? So how many choice do you have totally? All right, you can go to drop called a tree diagram. Okay, so this one is considered a tree diagram, right? 3 manufacturers, and then you can have a 2 car size, and then you have a different color. Each one have a different color. So this kind of diagram is called a tree diagram. All right, you can see all the detail in here, but this tree diagram sometimes when it get bigger is getting too tedious. So we just need to be using the fundamental counting principle, using the number of each category and multiply together. Look at it. You have a 2 car size, right? Three manufacturers. So you have 3 times 2 times 4. So basically you have 24 ways to choose a car in this case. All right. So multiply all these categories together. And what is a probability? Probability, basically, we have 3 different type of probability, all right? So one is called a classical one. Classical is called theoretical. So that means everything is in a perfect condition. And what is the probability you're gonna get? All right. So that's a classical and called a theoretical. Okay. And you're using the number of the outcome in the event divided by the total outcome. So that called a sample space. Okay. So that is the false probability formula you will have. So look at this one right here. Find a classical probability for this one. Loading a 6-size die. All right. So what is the event? You're gonna get a 3. Well, you're gonna have just 1 3 out of 6, right? So this is sample space is from 1 to 6. And then the event loading a 3 will be just 1. So it's 1 out of the 6. Event of loading a 7. Well, I don't have anything 7 here. So event of loading a 7 will be 0. 0 divided by 6 is still 0, right? And then loading a number less than 5. Less than 5 doesn't include 5. So you have a 1, 2, 3, 4. So you have a 4 divided by 6. Okay. And then 4 divided by 6, you have to simplify. Okay. If you want to write an exact answer, you simplify into 2 over 3, or you can convert it into decimal point, which is 0.667. All right. Since the probability is always less than 1, less than or equal to 1. So we usually like to use the 3 decimal point for that. Okay. And this one, if you do the homework, it usually will tell you how many decimal points you have to keep. All right. So the empirical one is also called a statistical probability. This is based on the real experiments. Okay. Based on the real experiments. So not everything will be ideal. All right. And the probability of the event, you're using the frequency of the event divided by the total frequency. Okay. So look at this one right here. This is the company response, company conducting the telephone survey, randomly select people to get an overall impression for their some kind of impression about 2000s. Okay. And then you have a positive, negative, neither, do not know, and they survey 1,504 people, and that is the real outcome response, right? And if you want to see what's the probability people respond will be positive, now you're gonna using the 4 or 6 divided by the total, 1504. Okay, and same thing if you want to find the probability of the negative, you will using 752 divided by the total. All right. So that is how you do the frequency in here. Okay. All right. Like I said earlier, you can put this one in an Excel or you can put it in a calculator, do that one by one right here, right? And then you can do this one. This should be easy to calculate. Okay, and then we're gonna have a law of the large number. Law of the large number, that means if you experience getting bigger and bigger, the real, the real experiment, the empirical probability, we are very close to the theoretical. All right, because like I said, if usually in a class, I tell people, say you do the experiment, right, and then you toss the penny for 10 times, and you can see how many times you're gonna get a head, how many times you get a tail. Well, some people only get 3 head out of the 10, right? Some people got 5 and 5. Some people got 7 out of the 10. So it's not always half and half. But if you toss this coin many, many times, like millions or billion times, the number of the head and tail, it will be getting very even. So that's called the law of the large number in here. Okay. The last type of probability is called subjective. This one is based on educate guess. All right. And that is called the subjective one. It's based on educate intuition or the educate guess, and it's an estimate. All right. A doctor may feel the patient have a 90% chance of full recovery. That's an educated guess. So this kind of probability is called a subjective. All right. So basically, that is three different type of probability we will talk in here. I will also talk, one is called a complementary event, right? So complementary event is only two type. Like I said, what is the chance of learning today? Okay, so if I say the chance of learning today is 30%, and what is the chance of not learning? Well, not learning will be 70%, right? Because learning and not learning add up together should be 100% or equal to 1. So if you have a complementary, that means it's only two type, okay? The complementary, you're using E prime in here. So the probability of E and the probability of E prime add up together should be equal to 1. And you can also using 1 minus that one, for the other one. Okay. All right, so that is a little bit summary for this one. Like I said, you also have a detailed video that you can go through this one on your own. All right, I just want to give you a very quick overview for this one. So what I'm going to do here is I am going to let you do the test 2 review already, yeah, because we cannot go through everything. And when you increase this test 2 review, and I will also, go through some of the concept, because the most important one here is for this class is I want to show you how to use calculator, okay? Because some of the video in the textbook, they explain the concept, but some of them did not do the calculator, which is the one we're gonna simplify a lot that way, all right? Okay, so we're gonna go through this review question, and then this will be a little bit similar to the test question, and then when we got to the calculator, we are using the calculator to help to answer the question. Okay, so the first one, determine whether the following statement is true or false, and explain it why. Probability event A or B, okay, so this is section 3.3, so you can see this one is using event A or B. If using A or B is called mutually exclusive or non-exclusive. All right, so go ahead, get a little bit. And then if you go through the chapter 3 detail, you will be able to look at what is mutually exclusive or not exclusive. Okay, so when you have a mutually exclusive, okay, if you have an event A and an event B have nothing in common, this is called mutually exclusive. All right, but if you have an event A also part of the event B, this is called not mutually exclusive. So if you have A or B, for this is mutually exclusive probability of A or B, you want to just probability of A plus probability of B together because they have nothing in common. You add them together, right? But if you have this one is not mutually exclusive, your probability of A or B, if you add all the A and B together, you add the middle part twice. You add this middle part twice. So you have to minus this middle part, A and B once. Okay, so that is not mutually exclusive. If you look at the formula C, okay, let me show you the formula C very quick. All right, so if you look at the formula C, okay, you should have this one right here, probability of the occurrence for A and B. All right, so look at this formula in here. You have A and B. probability. Okay, either A or B. So this is using all in here. Okay, using all. All right, so you're gonna have a probability of A is equal to probability of A plus B and minus A and B once if this one is not mutually exclusive. Okay, and if it is mutually exclusive, you just add A and B together because the combination of A and B will be 0 anyhow. So that is this one, right? Classical probability, empirical probability formula, complementary probability formula. So these formula are all in here. Okay. So those are all the formula. All right. We also have a permutation and a combination formula, but I was showing you we can actually using the permutation and combination from the calculator instead of using the formula. Okay. So that is the one I want to show you in here. All right. So which one? The probability A or B will occur is this one. Okay, so this should be minus, not plus. All right, this one should be minus in here. So the A or B occur so should be this one, should be D. Okay, not this one. If you go to the, even you just look at the formula sheet, there's a formula right here. Okay, so that one should be really easy to identify. Okay, the second one, the company is conducting a survey to determine how prepared people are for a long-term power outage, natural disaster, or terrorist attack, right? Frequency distribution is right here. So how do you use this table calculate this one? So what is the probability that the next person's survey is prepared? All right, so the probability next person survey is prepared. All right, so it's very prepared. Actually, it's called very prepared. Okay, so what's very prepared? Very prepared here is 280, right? So you gonna need to use 280 divided by the total. Okay, so I giving you a minute. Let's see anyone come up. How do you do this one? And first, this one did not giving you the total, so we will need to add a total on your own and then divide by using 280 divided by total. So giving you 1 minute to go ahead, trying to see if you can do this one on your calculator or Excel very quick. Okay, I don't think that we need a grouping. Just go ahead and do that on your own, trying to see if you can come up with the same answer. Okay. All right, some people already faster than me, already got an answer. Okay, so we have a total is 2206, right? So you're using 280 divided by the total. All right, and this one telling you you need to round to 3 decimal places. So you're going to round to 3. All right, so round to 3 decimal point will be 0.0127. Okay, so let's see. We have a 0.0127, 0.127 in here. Make it a little bit bigger. All right, so we type all the frequency and then we add all these frequency together. So this one is the total, right? And then you're using 280 divided by the total. So you got 0.127. That is the very prepared probability. All right. Any question about this one? Okay, the next one here is a study found that people who suffer from obstructive sleep apnea are a increased risk of having heart disease. Okay, identify two events described in the study. Do the results indicate the event are dependent and independent or independent? So let's give you a very quick, this is on section 3.2, right? What is dependent? Dependent, that means these two things are related. So that means if you study hard and you test score, this should be a dependent, right? Because if you study hard and you got a good test score, so that is a dependent. And some people say, I work out really hard. I want to gym every day. How about my statistic test score? Well, I think that should be independent. Even you go to gym very often, that is a good thing, but it doesn't increase your statistic test score, something like that. So I would say those kind of independent, right? So let's look at this one right here. Let's see, study and heart disease, sleep apnea and heart disease, study and sleep apnea, so having sleep apnea and not having it. Okay, so choose the correct answer. So are these events dependent or independent? How about A? What do you think about A? Is A dependent or independent?
Independent.
Okay, all right, let's be independent. How about B? How about B? If you look at this one right here, it already telling you, right? People find this sleep and heart disease actually have something related. So I think that this one should be dependent. Okay. Sleep apnea and heart disease according to this different statement here. So that's kind of dependent. All right. Study and sleep apnea. So there's nothing related in here. Okay. The rest is independent. Okay. Number 4, if you're loading a six size die, find the probability of each volume. Loading a 4 or a number is greater than 3. Okay. Loading a number less than 5 or an even number. Loading a 2 or an odd number. All right, so for this one, I'm gonna put you in a group and I'll copy this one right here, and I'll put you in a group. Let's go ahead and get a little bit discussion on this one. Okay, I'll give you 3 minutes, 3 or 4 minutes. Okay, so I'm gonna everyone make a little bit picture of this one so you know what it's asking. I'm not sure when I put it in a group, can you still see the screen or not? But if you take a picture in this one, everyone should have that. Okay, and I'm going to put you in a group. All right, we're gonna open the room. Okay, and I'll giving you this question back. Okay, we're gonna close the room. Okay, we are all back. Let's go ahead, type your answer here. Like I said, ABC, what's your answer? Can we type some answer in here? Okay, we have 0.5, 0.833, 0.667. Okay, very, very good. They are all correct. Okay, for that group. Yeah, okay, all right, good, good, good. Okay, we have a two group already answered. They are all correct. All right, so since we did all correct, we can just go ahead very quick. Probability of 4 or number is greater than 3, right? So you will need to identify are they mutually exclusive or not, okay? So we can write down like this one is 1, 2, 3, 4, 5, 6, right? That's the 6 size die. So probability of 4, so that's right here. Or a number greater than 3. Well, since number greater than 3 is all three of them, but we can only count the, you know, 4 one time. You cannot count the 4 two times. So probability of 4 or greater than 3, right? You're gonna using probability of the 4 plus probability of greater than 3, but you also need to minus probability of 4 and also greater than 3 once. So if you're using 4 as 1 greater than 3, you have a 1, 2, 3, 3 of them, right? And then 4 and greater than 3, that's one of them and divided by 6. So that is 3 divided by 6 or 0.5. Okay. Or if you don't want to use this complicated one, you just do not count the 4 twice. Okay. So that is you A in here. And then you B. Okay. So what is a B? 1 or 2 or 3 or 4 or 6, right? So there's nothing so B here, there's nothing repeat. Okay, so 1 doesn't include 2, so that's 1, 2, 3, 4, 5. So that's 5. out of the 6, and then you round to 3 decimal points. So I think that's 0.833, right? That way. Okay. 2 or 1 or 3 or 4, see here, same thing. There's nothing repeated. So you have 1, 2, 3, 4. So that's 4/6. You convert it into decimal point. All right. So there's nothing overlap. So you can just add them together because this is all. Or when you have an or, is using pretty much using addition. Okay. All right. Let's look at number 5. Statement true or false, right? If you're taking a test that has a true or false, a multiple choice answer, the event choosing for on choosing A or B on the multiple choice question is a simple event. Okay, we said that earlier, if we use a simple event, that means it's only one outcome. Okay, only one outcome. So I want you to read this very, very carefully and then choose your answer A, B, C, D. All right, give you a couple of minutes to read it and then answer that. Okay, trying to see which one that you choose, and you can type it on the chat. That way. Is it a simple event or not? Okay, let's go to look at the chat to see what we have. All right, we have a D, we have a A in here. Okay, so let's see. That's why we always say read it at least twice before you choose the answer. Okay. You are taking a test. Okay, this test has a true and false. Okay, and also have a multiple choice question. All right. The event choosing a false on a true or false question. Okay, so that is that is one outcome, right? And choosing A or B on a multiple choice question. So you're gonna have two outcomes in here. One is choosing a true or false question. Okay, that's one outcome. The other outcome is choosing A or B on a multiple choice question. So basically, this event has two outcomes. All right. So the two outcomes. So that means it's false. Okay. So it choose false is correct, but the event is not simple because probability of the true or false question and the probability of the multiple choice question. This got a little bit chopping in here when I download it. But the problem here is not a probability, it's the outcome, okay? Because it consists of two possible outcomes. It's not about the probability. All right. So it should be C. C should be the correct answer, right? Okay, so when it's not a simple event is depends on how many outcome you have. It's not based on the probability. All right. Okay, so we are very close. If you choose the A, it's very close, but it's not about the probability. It's about the number of outcome. All right. Okay, we are at the beginning of this one, so yeah. When you go through this one, it will be a little bit easier after you practice, right? This one is a regression line. Okay, you want to find a regression line, construct a scatter plot of the data, and using the regression equation to predict the value of y for the given x. So this is about 9.2 using the technology. Okay, will be much easier than using the formula. I can show you the chapter 9 formula. So which formula do we use? All right, let me show you the formula about chapter 9, right? This is a correlation coefficient formula. You can see this formula is really big. And this is how do you find a linear regression y hat equal to mx plus b. And that's the formula you find the slope. That's the formula you find the b. And that is, this formula is so big, okay? If you want to calculate this correlation coefficient, I'm sure the chapter video has, the book video has a step on how to use this one step by step. You know, if you calculate by hand, it will take 10 minutes at least, okay? Of course, the video doesn't have 10 minutes because they already organized. So how do you read this formula? You need to have a big sigma. Big sigma is the sum, the addition, right? So you have to multiply each x and y together first and then add them together. All right. And then this formula is you have to add all the x together and then add all the y together first, and then you multiply. So you will need to know how to do this formula. And this one, you have to square each x first, and then you sum them together. This one, you add all the x together and then square them. Okay, so you have to calculate this one by one individual first, and then come back to use the formula. All right, there's a video from the textbook. You go through all the detail, but we don't really require you to using this formula. We're gonna just go ahead using the calculator to find the linear regression equation. So if anyone still remember how to input the data, which I showing you how to do the scatter plot last time, right? How to using the TI calculator to do the scatter plot. Okay, so we're gonna go to stat, edit, and if you already have data here that you don't want, you just hit clear, enter, everything will be gone. Okay, if you have a calculator, you can also go ahead, open that, and then input that, practice with me together. All right, so this data is not that big. It should be really easy to input in here. All right, so we're gonna input X into L1, Y into L2. Okay, so if you have a calculator, your app, and everyone should have a calculator. It doesn't matter handset or app on your cell phone. That's all okay. Okay. When you input it, then just make sure your left side and right side are the equal length. Don't have one side shorter or longer than the other. Okay, otherwise it won't graph and it won't calculate. All right, and double check you just double check your answer. You input. If one of the input is not correct, you can just curse that and fix that really quick, right? So that's a good thing. You can just fix it individually. You don't have to retype everything in here. All right, so after you input, you can go to the main screen. Second y equal to anything with STAT is our favorite, right? So if you want to exit the state plot, you have to have a second. All right, and then hit enter. And make sure you turn on this scatter plot because every time you turn off the calculator, it go back to R. All right, the first one is the scatter plot. You have a L1 on X, L2 on Y, so that is correct, right? And I'm gonna hit graph. When you hit graph, you don't see anything, go to zoom state, zoom number 9. Anything with STAT is our favorite, okay? So that is your scatter plot graph, okay? And how do I find my linear regression? Same thing, we're gonna go back to state again and then go to the cal, okay? And then we're gonna using number 4, linear regression, okay? Go to number 4, linear regression, and then we hit enter. All right, and everything looks good. L1 on X, L2 on Y, and then we just hit enter. Now you have this one right here. Okay, you have this A and B. We usually this require you to run to 3 decimal places, right? So this one run to 3 decimal point will be 0.051. This need to run up, file above you run up, and then you times the X, right? And then plus B will be 14.634. Okay, so if I will write down my equation, let's write down my equation in here. Okay, so my equation for number 6 will be y equal to ax plus b, right? A is 0.051x. Okay, you have to have an x in here, and then plus b. So b is 14.639. So 9 need to run up, so that should be 34. So that's my y hat in here. Okay, that is my y hat. And I can plug this y hat into y equal to. Okay, so if I plug this y hat into y equal to 0.051x, okay, and then plus 14.634, and then we hit enter, we hit graph. Now we have this linear regression graph. Okay, and this graph is called, this line is called the base free of the line because it passes as many points as possible in here, and some of them is above, some of them is under, right? And this is called a residual. If you drop a little bit distant from here, above one will be positive, below this line will be negative, and then this is some together, positive, negative together will be all 0. So this line is called the base free of the line. All right, so that is 0.051x plus 14.634. Okay, and we can use this. So now you can choose the correct answer, right? So you can choose the correct answer for this one. Okay, you can choose the correct answer. And some people say, oh, B and C look all similar. Which one do you choose? Okay, so which one do you choose? In here, you will have to calculate a little bit, call a little bit of test point, right? You can look at this one right here. This one is 80, and then look at that. When x is 0, that's another quick and easy one to find, right? When x is 0, how much is y? Look at that. Look at that. When x is 0, y hat, this one 0. 0 times anything will be 0, right? So this y hat should be 14.63. So it's 14 point something. So you look at the y-axis in here. Which one is 14 point something? Apparently this one is much over, and then this one is much lower. Okay, even they look similar. So this whole thing is 60, right? So we can go to look at how many grid in each one in here. So let's go ahead. Then you choose B or C. Okay, anyone? Give it B or C. Give you a minute. Oh, okay. Okay, so is it B or C? So, okay, let's see. Let's look at a little bit our answer here. B or C? Okay, you will need to try to answer. Okay, even you answer incorrect, that means at least you're thinking. All right. As we said earlier, our y-intercept is supposed to be 14.6, right? So let me make this a little bit bigger. Make it a little bit bigger. All right, so let's look at B. So we have a 0 to 60 right here. So that's 1, 2, 3, 4, 5, 6. So each grid should be 10, right? So you do the math in here. So this one, the stories in here. So this each one should be 10. So this one right here, this 10, 20. So this should be 25, around 25. Our y-intercept on x is 0. This is supposed to be 14.6, less than 20. And this one apparently is about 20 because this should be 10. So this one right here, 10, 14, so should be C. C should be the correct answer, not B. All right, because you calculate each Greek here, it should be just 10. Okay, and our when x is 0, the y-intercept, the y-intercept, y-head should be just 14 point something. So C is the correct answer. All right, so that is a little bit tricky, right? Because even you know how the graph would look like, you will still need to know how to find the intercept in here. Okay, read this one, not reading the calculator, because calculator grid is a little bit different than here. Okay, and then we're gonna predict the value for x for the y when x is 502. Some people say, oh well, do I have a 508 in here? I have a 519 in here. Can I just estimate in from here? No, even this one has a 502. This is a real value, right? We want to predict the predict value have to using the formula we just have. Okay, so we have to use this formula to calculate the predict value. Okay, all right, so let me see. 502. So when x is 502, how much is y head? So you're using 0.051 times 502 plus 14.634, right? And sometimes people say, how do I calculate this one? Well, when you go to if you're using calculator to calculate this one, you don't type a y head. All right, so let me just go ahead and show you how to do this one in a calculator. Okay, so you're gonna have to second more, go to the screen to calculate this one. So 0.051 times 502 plus 14.634. Let's say you calculate in here. So you're gonna have a 40.234. Okay. Oh, 236. Sorry. All right, so that is your answer in here. Okay, 40.234. Oh, this belong to the integer apparently in here, so that should be 40. Okay. All right. So, and then same thing. How do you predict when x equal to 644? Choose the correct answer, and then predict x equal to 315. All right, so, and then predict x equal to 730. Okay, so using the same formula, you just using this same formula, you just replace the x into a different value in here. Okay, just like the one replace 502 into 644, and then replace 502 by 315 by 730. Okay, same calculation. All right. Okay, let's look at number 7. Probability experiment consists of loading of fail 16 site. Okay, this is a 16 site die. Number from 1 to 16. Okay, so we want to find a probability of event of below. So loading at 6. Okay, give me a really quick calculation. Let's see how much is that. You have to run to 3 decimal point if you have a fraction. If you have a decimal point. All right, so this one is rounding. This is numbering from 1 to 16, right? So that should be, and you're gonna have just how many six you have? Loading just a 6. So a 6, that means it's only one 6. Okay, so that is 1 divided by 16. Okay, 1 divided by 16. All right, so it's round to 3 decimal points, 1, 2, 3. So you're gonna need to round to 0.063, right? So that is this one right here. Okay. All right. Choose the 3 formulas that can be used to describe complementary event. Okay, so if you look at usually, if you look at this square, it's multiple choice. That means more than one answer will be correct. If you see this radio button, right? If you're using this radio button, that's a single choice. You either just choose one, okay? And that's kind of a little bit standard in here. When you see the square button, that means you can choose, more than one, or maybe just one, but you can choose more than one. So sometimes a tricky part is here is you need to choose as many as possible when it's correct. All right, this one is 3 formulas. Okay, so this one is better telling you have 3 formulas. You can do this one. All right, so this one is about a complementary event, right? So we said that earlier, the complementary event, that means only 2 categories, like a running and not running. And then these 2 added together should be equal to 100% or equal to 1. Okay, so what 3 are the correct answer? So type it in the chat section, trying to see which 3 will be the correct answer. Everyone give it a try. Okay, let's check some of the answer. Okay, all right, very good. We have a ABC, ABC. Okay, they are all correct. Yeah, ABC will be the correct answer. Yes. 3 is A, B, and C, right? You have a probability of E plus probability of the complementary or E prime is equal to 1, right? And then you can have a probability of E prime equal to 1 minus P of E, or P of the E equal to 1 minus P of E prime, right? So using the C, and then you can introduce A and B. So yeah, that is the only 3 are correct. The rest are incorrect. Okay, all right, very good job. Okay, now let's look at this one. Okay, I want you to read the question carefully and then choose the correct answer. Okay, two variables have a positive linear regression. Okay, so what does a positive linear regression mean? That means it's increasing, basically. Does the dependent variable increase or decrease as the independent variable increase? What if the variable have a negative? How about if this one has a negative linear regression? All right, so let me show you what is positive, what is negative. Look at that. Okay, so this is called positive. Okay, linear regression. This type is called negative linear regression. All right, so the first one right here is this one has a positive. Okay, this one has a positive. Does a dependent variable increasing or decreasing as the independent variable increase? Good. What does that mean? So this x-axis horizontal, we call it independent. All right, the y-axis we call it dependent variable. Same thing, the y-axis is called dependent. X-axis is called independent. Okay, so when the independent variable increases, so that means this one is from left to right, right? This is x, this is y. All right, we usually don't call the x and y, we call it dependent and independent. Okay, but you know the independent is x. So when the independent increases from left to right, the dependent is should be also increase for the positive one. Okay, and then from left to right, this independent increase, right? And then if it's negative, the dependent is decreasing. All right, so that is this kind of relationship in here. Okay. All right, let's look at number 10. Restaurant offer a $12 dinner special. That's a 5 choice. Okay, so what are those 5 choice? 5 choice of an appetizer, 13 choice of entree, and 4 choice of dessert, something like that. Okay. All right, so how many different meals are available on this day? An appetizer, an entree, and a dessert. All right, give you a minute. Let's find out what is the total ways to choose this 3-course meal. Okay, let's type it in the chat to see what you have. Okay, let's look at what is the answer here. All right, 260, 260. Okay, very good. Those are the correct answers. Okay, you have a 3-course meal. So what do you do in here? You basically just the total ways. Okay, the total ways. We said earlier, you're using m times n times r, all of them multiplied together. Okay, so we have a 5 choice of appetizers. So that's 5 times 13 times 4. Okay, so that's 260. So that's exactly right. All right, very good. Okay, number 11, what is the sample space? And how many outcomes in a sample space? Okay, I give you another minute. Let's answer this one. Identify the sample space of probability experiment and determine the number of outcome in a sample space. Okay, so you randomly choosing a number from the multiples of 5 between 21 and 49. Okay, let's type it in the chat to see what you get. Okay, all right. So we have 25, 30, 35, 40, 45. That's exactly right. And you have a 5. Yeah. So the answer here is 5. Okay, very good, very good. That's exactly right. Okay, so because between 21 and 49, right? So you have to, the first one you start, have a multiply, it will be 25, and then 30, 35, 40, 45. Okay, so those are the sample space, and that's 5 outcomes. So that's exactly right. Okay, all right, very good. Okay, let's look at number 12. A car is selected at random from a standard deck of the 15 playing cards. Okay, so what is the standard deck of the 52? That means doesn't include jokers. Okay, find the probability of each event. Some people say, I never played a card before. How do I answer this one? Well, unfortunately, this chapter probability, we use a lot of playing cards. So you will need to go to, I think I posted a picture on somewhere in the Formula C area. Um, okay, let me see if you go to there. Um, okay, I think if you go to this link, you should be able to find some of them is called maybe not. I'll drop a little bit picture right here. Okay. All right. So let's go to look at my the car, standard car. Okay. So you have this one is considered a standard car. Okay. So if you never played the cars before, you can look at this picture. All right. Look at this picture in here. So how many red car, how many black car, right? If you want to consider the red car, the heart, the diamond, these are the red, right? And the club and the space, those are the black in here. Okay, so and sometimes the jack, queen, and king we also consider a face card because these three type has a face. Okay, so A doesn't have a face. So this is how many face card we have? We have a jack, queen, king. So 3 times 4, you have a 12 face card in here. Okay, so this will be a good sample space if you look at a standard playing card. Okay, and then we're gonna come to answer this one right here. Okay, so the total is 52, right? You want to randomly select a three of a black 3 or a 6. Okay, a black 3 or a 6. All right, so this is all. So that means you will need to add black shoe and a 6 together. But since some of the black shoe also have a 6, so you will need to minus the common part once, or you don't count the common part twice. Okay, so let's see how do you do this one. I'm gonna give you the picture back. Black block. So if you count this block here, this has 13, right? And then this another one has 13, got 26, or a 6. If you look at the 6 here, they got 4 6 in here. But if you count the 4 6 in here, you count the spade and the club twice. So you will need to minus 2 of them. Okay, does that make sense? So if I using 13 plus 13 plus 4, I will need to minus these 2 ones. or I don't count this one in here. I have a 13 plus 13, 26, and then just add these two red one. Okay, so that would be 28. 13 plus 13, 26, and plus this one and this one. That's 28. 28 out of what? 28 out of 52. Okay, and then you round to 3 decimal point. All right, so let's see. 28 out of 52. Okay, so it's 0.538. All right, you round to 3 decimal points. Since the fourth digit is 4, so you round it down. All right, so that is how you do this one right here. Okay, all right. B, probability random select a diamond or a king. All right, I want you to go ahead and do this one right here. What's the probability of randomly select a diamond or a king? A diamond or a king. Okay, so this one is the diamond. Okay, diamond or a king. Or remember, or you have to add them together. So this is a diamond, right? Diamond, you got 13. So when you have a 13, you already add this king in here. Or a king, if you count the king as 4, now you count this one twice. Okay, so you have to minus this one once, or you just add this 3 only, don't add this again. Okay, so if you use 13 plus 3 in here, that would be 16, right? But if you use 13 plus 4, you will need to minus this one once. Okay, so it's 13 plus 3, so that's 19, right? So you have a 19 out of what? Out of 52. So now it's 0.36. Okay, let's see what is the probability of selecting a diamond or a king. Okay, a diamond. All right, so diamond is 13. 13 plus okay, diamond 13. And then, or a king here, you add 3 more king. Don't add this again. If you add this again, you have to minus that once. Okay, so it's 19 over 52. All right. Okay, how about the number C? Probability randomly select a 10 or a face card. Okay, and then we said earlier, which one is a face card? Face card is J, Queen, or King. Okay, so J, Queen, or King, this is considered a face card. Randomly select a 10. So how many 10 you have? You have 4 10s, right? And 10 and the face card, it doesn't overlap. So you're gonna just add all of them together. All right. So that's giving you a quick calculation. How much is that? Okay. Anyone give you a quick calculation? Let's see how much is that. Okay, 0.308, that is correct. Okay. All right, 0.3.2. That is correct, right? So you're gonna have a 12 plus 4. So that's 16. Okay, 16 divided by 52. Okay, and then this is round up. All right, okay, so that is good. So that's how you do this one, because 10 and face card do not have an overlap. If you don't have an overlap, that means mutually exclusive, right? Mutually exclusive, you just add them together. Okay, this one is finding the probability. So what's different of finding the probability? That means you have to divide by the total, okay? If you want a probability, you need to divide by the total in here. So 2 cards are selected from a standard deck of 52 playing card. The first card is not replaced before the second card is drawn. I think this has a little bit of, oh yeah, it's selected. the first card is not replaced before the second card is selected. Find the probability of selecting a club and then selecting a heart. Okay, so which one is a club? Which one is a heart? Okay, club and a heart. Remember, the card is not replaced. Okay, the card was selected from this one. The first card is not replaced before the second card is selected. All right. So find the probability of the selecting a club and then selecting a heart. So this is an N. Okay, probability of selecting a club and then selecting a heart. So when you have an N in here, how do you do this one? It's using multiply. Okay, you can go to the key formula here, number 3, chapter 3. Okay, probability of occurrence both event A and B using the A and B. So probability of A and B, this is dependent or independent, right? Probability of A and B is using probability of A times the probability of the B given A is already happened. If these two are independent, you just multiply those two together. Okay, so that is this one right here. All right, so apparently this one is dependent, right? Because it didn't replace. It did not replace. It said it did not replace. Okay, so what is the probability selecting a club? All right, number 13, probability selecting a club. Let's do this one right here. And then we're gonna go to see probability of selecting a heart. Given the club is already up. Okay, probability of selecting a club here. How many clubs we have? We have a 13 out of the 52. Basically, if you simplify this one, it's 1 out of the 4. Okay, and probability of selecting a heart, given the club is already out. So what does that mean in here? So how many heart do I have? Well, I have a 13 heart. Okay, but given the probability of the one club is already out, it didn't replace. So my sample space is only 51 there. I do not have a 52 anymore. Okay, so that's the condition. Given this condition is already happened. All right, this one probably a little bit extra in here, right? And then we just multiply these two together. Okay, multiply these two together. Multiply 1 over 4, or you can use 13 over 52. Doesn't matter if you don't want to simplify. Okay, and then just multiply these two together and then convert it into decimal point. So 1 times 13 divided by 4 times 51. All right, and then you can put in a calculator and put in an Excel. Doesn't matter, right? So you have a 1 times 13 divided by 4 times 51. Okay, and then 1 to 3 decimal point, right? So 1, 2, 3. So this need to round up 0.064. All right, so that is how you do this type. You have to find each probability first and then multiply them together. Okay. Any questions? Okay, let's look at number 14. Number 14. Okay, in a sample of 1,000 US adult, 173 think that most celebrity are good role models. Okay, 2 adults are selected from the sample without replacement. So what is without replacement? That means 1 is out. The total gonna be this, right? So that is this one without a replacement. If with replacement, that means the sample will be still 1,000 again. Okay. All right. So we're gonna answer A through C in here. Okay, so first, find the probability that both adults think a celebrity are good role models. Okay, 1 to 3 decimal place. All right. Okay, I'll give you a minute. Let's see how do you do this one. And then let's see if you can come up with the answer. Okay, so first, let's see how we set up this one, right? Setting up is important. The calculation should be really easy in here. Okay, so the probability 2 adults, so the 2 adults, so that means the first one, and the second one, this should be an n, so that should be multiplied. Okay, probability of the first one we think is a good role model will be 173 divided by 1,000. Multiply the second one, we also think is a good role model, right? So remember, it didn't replace without replacement. So you have a 1 is already out. So the second one we think is a good. So this is we think is a good role model here will be 172. Okay, because 1 is already out. Same thing, the sample space is gonna be 999. You have the minus 1 in here. Okay, why the numerator and denominator both minus 1? Because you want to think of both adults thinking the same thing, right? Thinking all the good role models. So the first one is already out. This 173 will be 1 less. Okay, and same thing as a sample space. All right, and then you just multiply the numerator with the numerator, right? Okay, when you put in a calculator, make sure you have a parenthesis, otherwise you will give it the L. Okay, so you just multiply this one and divide by the denominator and 1 to 3 decimal point. That's how you do that. Okay, we can just calculate one of these. All right, so we have a 173. All right, and then you run to 3 decimal point, right? So how do you run to 3 decimal point? This 7 run up will be 0. So that will be 0.030. Okay, so now you need to know how to run to. We have a 0.029785, right? And then we need to keep 3 decimal points. So that means that's the 3 we need to keep. So this one is file above, we need to round up. Okay, so round up, this one will become 0, this will become 3. All right, so that is 0.03. You do need to include this 0 at the very end. Even the last digit is 0 because you want to round to 3 decimal point. Even mathematically speaking, these two are equal. But if you write down this one, you only have a 2 decimal point. Okay. If you write down this one, you have a 3 decimal point. That's the difference. So sometimes if they are picky, you might counter this one wrong because they consider you did not round to 3 decimal point. So go ahead, just keep the last 0 in here. Okay. All right, so that is the first one right here. The second one, find the probability that neither adult think most celebrity are a good low example. So what does neither mean? Well, neither, that means none of them, right? None of them think they are not a good low example. Okay, so neither adult. So that means okay, so 173 think they are a good example. How many of them will think they are not a good low example? Okay, not not a good low example, not a good low models. Okay, so this one right here, you're gonna use 1000 divide minus 173. Okay, so this should be 9. Someone just trying to get in. Okay, so 1000 minus 1000. Okay, so that is 827. All right, so basically 800 820 to be clean writing. 827 think the celebrity are not a good role models. Okay, so now you can go back to do the similar the one we did on A, right? So neither one of them, neither one of them, that means both one of them. So the first one and the second one, okay, this one, yeah, both second one, first and the second, and this one is not a good role model in here. So you want to use the first one times the second one. So the first one is 827 divided by 1000, right? And then times the second one, also think is not a good role model. So you're gonna have a 826 because one is already out. And then divided by 999, okay? And then you can go to multiply numerator and denominator together. All right, so you can put in a calculator and then 827 times 826 divided by 1000 times 999 and then round to 3 decimal points. So that's how you do this one. Okay. All right. Find a probability that at least one of the two think most celebrity are a good role model. All right, so what does at least one mean? At least one role model. One, that means you can have one adult think is a role model, or two adults think they, or both two adults think they're good role model, right? And actually, this one is a complementary for neither one of them think is a good model. Neither one of them. Okay, it's a complementary. So if you calculate the B, you can just using 1 minus B will be giving you the C. So let's go ahead and calculate what is our B in here earlier. Okay, so we have 827 times 826. Okay, divide by 1000 times 9. Oh, I'm sorry. This is multiply. 999 Okay, and then let's give you a 1 to 3 decimal points. So this is 0.684. Okay, 0.684. All right. So 0.684, that means neither. That means none of them think it's a good role model. All right. And this one is a complementary for at least one. Okay, at least one can be 1 or 2. All right. So we can just using for the C, you can just using 1 since they are complementary. And then this will be 316. Okay, if you need to use calculator, just use calculator. Using this one, subtract from 1. All right, so that is how you do this type of question. Any question about this one? Anyone has any questions? Okay, last 2 questions. Okay. For the given pair of events, classify the 2 events are dependent or independent. Okay, so let's see the first one, flipping a coin and getting a tail. Flipping the same coin again and getting heads. Okay, so let's see these 2 events. Dependent or independent. So the first event here is flipping a fair coin, right? And then you're getting a tail, getting tails. And then the second event is flipping this same fair coin again and getting heads. Are they dependent or independent? So the way you think dependent or independent is something like that. If I flip this coin the first time, I get a tail. And I flip the second time, I get a tail again because the first time I get a tail. If because the first time I get a tail, the second time I will get a tail. If that's the relationship exists, that means it's dependent, right? But if the first time I get a tail, the second time I will get a tail or not, it doesn't really matter. It doesn't relate to the first time I get a tail, right? This will be independent if it's not related. So think of that carefully and then choosing the correct answer. And then let's type your answer, trying to see A, B, C, D, which one do you have? Okay, so this one, the best answer here should be C. These 2 events are independent. Okay, because if we feel the falcon getting tails, it doesn't affect you to getting the head. So it is independent. So why is it independent? Because the occurrence of the one does not affect the probability of the occurrence of the other. Okay, so that's the good statement in here. All right. If you go through the video section for this one and do more homework, you will a little bit more clear on that. All right, let's look at the last one for today. Determine the number of outcomes in event. And again, this one is random sample, random order. So that's why you can see this is 3.1, but it's in the last one because everyone is randomly ordered in here. Determine the event is a simple event or not. Okay. A computer is used to select random number between 1 and 9, include 1 and 9. Okay. Event A is selecting a number greater than 5. Okay. Is this a simple event or not? And why? Okay, let's type it on the chat to see if we can get this one right. Okay, so this is a number between 1 and 9 inclusive. That means include 1 and 9, right? Okay, so let's see. Let's check our answer here a little bit. Okay, no, more than 1. Yes, so that is okay, so look at this one right here, right? We have randomly generate the number between 1 and 9, inclusive. That means include 1 and 9. Okay, and then event A is selecting a number greater than 5. Okay, so how many number will be greater than 5? You're gonna have a 6, 7, 8, or 9. Okay, so those are the number greater than 5. Greater than 5, that means didn't include 5, right? If you have a greater than or equal to 5, now you will include 5. But include just greater than 5, that means it didn't include 5. So you have at least what? You have a 6, 7, 8, and 9. You have 4 outcomes. Okay, you have 4 outcomes. So that means this event A has 4 outcomes. Okay, so is this a simple email? Of course not, because it has more than 1 outcome, because you have a total have 4 outcomes in here. Okay, so that is how you answer this one. You're gonna have a 4 outcome. Okay, and the answer will be no, because it has more than 1 outcome in here. All right, so that is the one I am going to talk today. I also want to let you know where to find a correlation coefficient. Even our exercise do not include it, but if you go to the chapter 9 in here, if you go to chapter 9, right? Chapter 9 right here, one of the formula is finding the correlation coefficient. So what is the correlation coefficient? Correlation coefficient R actually is between -1 to 1. This is not a probability. This is called a correlation coefficient. Okay. So when a +1, that means everything is positive. Line up, all the scatter plot line up perfectly in a straight line. So this kind of thing, R will be 1, right? And then if the coefficient line up, if this line up perfectly in a straight line, but it's decreasing, this R will be -1. Okay. So that is the correlation coefficient. And this is to indicate how strong relationship of X and Y, of the dependent and the independent, right? So that is the R. And how do I find the R from the calculator? Okay, let me show you very quick, since we already have a data here. Remember, when I go to my state and I go to the cal, and I look at using number 4, I using the linear regression, okay? And then when I hit the calculate, it already give me the R in here. So this R here is the correlation coefficient, 0.917, if you go to 3 decimal point, right? But sometimes, probably the first time, sometimes your R did not come up. When you do the linear regression, sometimes it will only showing you AX plus B, showing you A and B, did not showing you R squared or R. So if you did not show up, how do you make the R show up? You go to the catalog in here, okay? So go to the catalog. So how do you get to catalog? Second 0 will be the catalog, okay? And then you will go all the way to diagnostic. All right, go all the way to hit a D. Okay, diagnostic on. You need to turn this one on. All right, and here enter one more time. And when it's saying done, all right. The good news is sometimes the calculator, this diagnostic, it turn on all the time, unlike the scatter plot, you have to turn it every time. This is sometimes, especially if you have a handheld calculator, it stay on or once you turn it on, right? And then you come back here to do the calculation, and then you do the linear regression. And then if you didn't have the R earlier, this time you will have a R because you turn on the diagnostic. That way it will show the R. Okay, so just make sure that you know sometimes the calculator do not show you the R, where to turn it on. Go to second catalog, okay, and then go all the way to final diagnostic. Okay, for the diagnostic, and then hit the enter twice. And then when it's showing done, that means the R will show up when you do the linear regression. All right, so that way you don't have to use this big formula to calculate the R. That's really easy to find it from the calculator. Okay, so that is giving you the quick review for the test 2, which includes chapter 3 and 9.1, 9.2, chapter 9, you can all using the calculator for sure. Okay, any questions? Anyone has any questions? I'm going to stop the recording, and I'm going to stop the recording. So if you have any question, I will stay online. This will be a good time to do the one-on-one Q&A if you have.